everybody. Welcome. I'm super excited to be back here and really loud in your ears. Last time I've been up here, I think it was about 10 years ago for a first conference, and I haven't been back since, so I'm glad to be back. Unfortunately, just for a day, they already called me back to some other offsite I have to run back to. But yeah, I'm super excited to be here and talk to you guys about artificial intelligence and machine learning a little bit. Who has been to RSA this year? Show of hands. A few of you. I guess the rest is aware of the RSA conference in San Francisco. Crazy event floor where like hundreds of companies are showing their security products. I was walking around on the show floor and got really upset because pretty much every company had machine learning somewhere in their marketing, and half of them were talking about artificial intelligence. The problem was, as soon as I actually went up to the booth and asked them what they're doing and looked behind the curtains, and I've looked at a lot of those companies and what they do, it's really not machine learning. It's not artificial intelligence, what they're doing. So this is how this talk came about. I'm like, all right, let's just talk about this topic. And putting together the title, I was going to be a little provocative and said, you know what? If we look at security in the last, I don't know, 15 years, not that much has actually changed. So this is the topic that I want to discover a little bit with you guys in the next 45 minutes to an hour. I have to say this is what I'm talking about is not in my capacity, is in any way associated with Sophos. That's my day job. This is more of a fun thing I'm doing that has nothing to do with the company Sophos at all. So who am I? Some of you I have met before. Most of you probably don't know who I am. Currently I run security analytics for Sophos, which you probably know the company. I have spent pretty much my entire career on the data analysis side for cybersecurity. So I've worked at IBM Research, where we worked on the first SIM product really called Tivoli Risk Manager. Not sure if anyone remembers the Tivoli line of products or still has to use them, sorry. I worked for ArcSight, was at Splunk, and then started my own company, Logly, where we basically built a cloud-based log management service. I'm not sure, maybe some of you have used or are using Logly. And then in the last 5 years, or sort of the 4 years before Sophos, I was running a lot, doing consulting for large organizations, working on big data deployments, working on data science problems with large global companies, and figuring out how do we get access to the data, how do we make this data understandable that we're collecting in a SOC. And so a lot of the things that I will talk about today also come from that. So I have a little bit of a knack for visualizing security data. I've been visualizing data for probably about a decade at this point. A bunch of visualization tools and open source things. And I will show you some examples in the talk here also. Outside of that, I have a little bit of an interest in Zen meditation, so if anyone wants to talk about that, it's probably almost more exciting than security. All right, so if the slide comes back up, a little bit of a provocative premise for the talk, as you saw in the subtitle, is that cybersecurity hasn't really changed in the last 15 years, right? I know this is not necessarily true. We have definitely made some inroads, and we've been able to come up with new technologies and things like that. But I will show you a whole bunch of examples where I think we're really not that different from 15 or 20 years ago. We still have a lot of the same problems, as I will show you. And looking at sort of what other disciplines have done, and then trying to see that all these companies are trying to do machine learning and artificial intelligence and I don't know what. But if we look at other, the slides keep freshing up here. If we look at other disciplines like weather forecasts or forecasting election results, for example, those are two areas where I would think after, I don't know, hundreds of years of weather forecasting and dozens of years of trying to predict election results, we would actually be a little better off in predicting who is going to win elections. Look at the presidential election in the US, right? People were saying that 80% chance that Hillary Clinton was going to win. And then what happened? So an 80% chance. He was not like 60 or 65. No, he was 80%. We got it completely wrong. And this is a problem where I think we understand the inputs and what we're looking for, but we still can't predict things. Now, companies out there in the security space are saying, well, we have a much more complicated world where we're trying to model how each of you use computers and machines and interactive systems, and then we find anomalies through some kind of algorithm, call it artificial intelligence. So if we can't solve weather and elections, how are we going to solve security? You're just going to miss a few slides here. I'm just going to talk to them while we don't have them. So what I want to do quickly is look at a few areas in security and be a little provocative and show you that we haven't really changed that much. We're going to look at firewalls and IDSs and so on. And I'm going to be very provocative and say nothing has really changed. Then I will briefly talk about machine learning and artificial intelligence, pivot a little bit into visualization, and then want to look a little bit forward on what I see in the field of interesting technologies, interesting approaches in cybersecurity that I think are going to probably make a little bit of a difference out there in the next years. Here we go. So first topic, firewalls. If you have configured a firewall lately, and you have configured one maybe 15 years ago, it's still pretty much the same, right? You get the box out of the packaging, you install it, and then you have to start writing rules. Well, it's really still very much the same as back in the when you configured IP tables or PF or something like that. You have to figure out what is the right rule set. Suddenly the rules get really long. You have problems that there is rules in there that are never triggering because you wrote it in the wrong order. You have rules in there that are stale because for some project you had to add an exception. So there's entire products that help you audit firewall rule sets to eliminate all this waste that you have in there. So really not that much has changed in terms of writing rules. When I ask people, hey, you have a firewall, how do you analyze your log files? I generally get blank stares and they're like, we look at the logs every now and then, we have a problem. But do you proactively analyze your logs? Show of hands, who proactively looks at their logs? Well, there's a few of you, all right. But then I might dig a little deep. Okay, what do you do? Well, you might look for certain IOCs, you might do some command line stuff. Maybe you have a product you put it into. Maybe you put it into like a Splunk or an ArcSight or something like that. But I hardly ever see some sophisticated way of really understanding what's happening in the log files. This is an example that I've been using for many years now on visualizing some firewall log files. This is called a tree map, where this is showing you the traffic of, I think, about a day on a small firewall. There's not that much going on here. But you see sort of the red areas are the firewall blocks, and then the green is the traffic that has passed through. And there's certain patterns in here that you can find very quickly, and it helps you sort of focusing your attention to the areas that might be of interest in that firewall, like the big red block here in the middle. And I always challenge my students when I teach a class at Black Hat on visual analytics, and I asked them, what is this? There's traffic from some IP address going to a multicast address on port 427. And I ask people, what is 427? Anyone know? And I have analysts in the room that do this all day long, looking at log files. 427 is bonjour on the Mac, right? It's this beautiful protocol where a machine basically says, hey, I'm here. Who wants to talk to me? By the way, this is my name, and this is my capabilities that I have. Do you want to connect to me? So fortunately, that was blocked on the firewall. It wasn't let out of it, but that's probably a misconfiguration of a system right there. So this is a way that we could look at logs, but I don't really see many products that would have something in them. If we look at IDS, IPS, we still have a ton of false positives. We have a hard time prioritizing alerts. So if you get the data out of the IDS, well, which ones are you going to work on? Which ones really matter? SSL is a problem, right? You have encrypted traffic, so you can't really look into the packets. You have to do termination, and that's a lot of CPU cycles. It's not that easy. And then signature writing is still a very, very manual process, right? You have to have very skilled people writing these signatures. They have to be optimized for speed and all these kinds of things. So really the same as a long time ago. Threat intelligence. All right, we didn't have that in 1999. We didn't call it that, right? But if you think about it, threat intelligence is nothing else than a IDS signature. Like if you look at emerging threats and you download the Snort rule set, there's a whole bunch of rules that it's just a list of IP addresses that are known, botnet addresses or whatever the domains that are blocked and things like that. So it's really just a way to share some of these indicators a little easier. Some of these lists get pretty big today, right? You might have 100,000 entries of domains you want to check. Well, I challenge you, how do you do a matching of all your incoming log traffic, say you have 100,000 events a second, how do you match that up with a list of 100,000 elements? It's actually a pretty hard problem to solve. You need to have some interesting algorithms, maybe something like Bloom filters, and some pretty beefy hardware to do that. I have companies that told me they would pay some pretty good money if I could solve this. And there are companies, maybe one of the sponsors, that do something like that. But then also, the next thing I usually ask companies is when they have a threat feed, it's like, well, do you ever age out your old indicators? Right? An IP address doesn't stay bad forever. Usually, the infrastructure comes up, it's active for, I don't know, 5 minutes, 10 minutes, an hour, maybe a day, maybe a few days. But then it cycles, right? So the IP address is going to be good again. So in Amazon, it's going to be a legitimate service. So you have to age these things out. And anything that often the companies I talk to, if something is older than 5 minutes, the IPs are, like the intel is useless. So how do you share something very, very quickly, almost in real time? Data leak prevention, another one. Have you ever looked at one of these systems under the hood and configured, like on the command line, some of these rules? It's some of the stuff is horrible. They probably have gotten a little better. But in the end, they're just IDS engines. Yes, there's some interesting technology where you can register documents and it will actually look at the text and it will find it even if you put it from a Word into an Excel document. It does some intelligent hashing and things like that. But in the end, DLP is really not that exciting, I think. Passwords, right? We're still using passwords. We've used them forever, and it's still one of the biggest problems we have. Sure, there's some two-factor authentication stuff out there. There's some interesting products that are trying to solve the problem of passwords. But in the end, we're still having a really big problem with passwords. There are zero-knowledge protocols. If you guys have studied crypto a little bit, right? There's protocols that actually the password is never sent on the wire, but you can still make sure that the other party actually knows the secret. I haven't seen a product really implementing that, and we had this technology for years. I guess the problem is the underlying public key infrastructure. We haven't really solved that problem of being able to really identify someone and make sure that you're really the other person. But that's something that's probably should come from the government or something like that. Well, speaking of passwords and firewalls, in a Windows environment, you can generally, in a company, you can go up to a machine and you can log in with your AD credentials on my machine, or I can go to your machine. Whoa, this suddenly, it's maybe okay from a security perspective, but if you're on the analysis side, suddenly things get really interesting because now I have to correlate the IP logs, so all the flows, to the user that's actually on the system. So I need to get the AD logs, correlate all that, and that gets pretty complicated. Why not just, I mean, no one should use my laptop. Like, this is my machine. I probably don't want to have any of you logging in here with your credentials. And I mean, there's a guest account on here also, which makes things pretty bad as well. If I let you use my computer, and then there's some bad traffic going out, and we do some net flow analysis, suddenly I'm going to be convicted for the stuff he did, right? Why don't we just stop that? And then why the hell is your laptop allowed to talk to mine right now in this network? There's no reason he should be connecting directly to my network or to my computer. So there's a few things that are just kind of interesting, or something like BCP38, filtering on the border firewall or the border router to prevent spoofing is something that's not that hard to implement. There are some large ISPs that tell me that it's not that easy, but in general, this is sort of hygiene of the internet, and we're still not doing it. We know how to do it, and most people are just lazy, or they don't have the incentive to really do it. Vulnerability scanners, woo, we call it vulnerability management now, right? Very different. Look at those interfaces. Have you looked at a vulnerability scanner lately and looked at their interfaces? It's horrible, right? It's lists of vulnerabilities. This is an open source tool. where I pasted in one of my screenshots. But this is a visualization of some vulnerabilities on different machines. I have not seen something like this in many places. There's entire companies that do nothing else, that build interfaces or sort of build on top of all these different scanners, right? There's a couple of companies out there that consume that scanner data and basically mock it up differently. Why is that capability not back in the vulnerability scanners themselves? I don't get it. SIM, who's using a SIM? Splunk, ArcSight, Q1, Nitro, whatever you have. Bunch of you. Jesus, we had those in '99, right? We still struggle with parsing data. One of the biggest problems. One of the things, a lot of you, if you actually use a SIM, you probably had the issue with source and destinations being the wrong way around. If you do any analysis and your source is not the source, but it's actually the destination, if you look at net flows, humongous problem figuring out what's the real source of the connection and what's the destination. We haven't solved that yet. We have a hard time writing rules, like how do you write detection rules, correlation rules across the different data sets to really come up with interesting data. We don't know how to prioritize alerts, right? You have lists and lists of alerts that analysts are having to go through, and it's just a pain. It's a lot of work, and we have to work on a lot of low priority stuff just because we find out, oh, that's right, that was Joe accessing the internet again. It's okay, don't worry about it. Well, then we have security analytics. We definitely didn't call it that back in the day. But if you look at security analytics, broadly said, it's correlation, it's UEBA, user and entity behavior analytics. So just basically monitoring what does a machine do in the network, and is it suddenly changing its behavior, and does it look suspicious at some point? It's a little bit of orchestration and automation and maybe incident response. We had all these pieces. Guess what? Your SIM can actually do monitoring of behavior of machines. I talk about ArcSight because that's what I know best, but every other SIM can do this too. You use a data monitor. You can actually monitor the statistical sort of number of bytes transmitted or the volumes of traffic, and you can set triggers on that. So it's, and I tell this to security analytics companies, first they say, the SIM cannot do this. I'm like, yeah, let's sit down, let's do it. I can show you right now. And then they're like, well, but we make it easier. I'm like, okay, maybe that's a value proposition, but it's not really changing anything. All right, so that's just a few examples to maybe be a little provocative and let you guys discuss this in the next couple of days also. And I want to be clear, there's definitely things that have changed and have gotten better, but in general, there's a lot of things we can still solve, so there's still a lot of opportunity here. So let's talk a little bit about machine learning and artificial intelligence. I will give you a brief definition of what that actually is, and I want to discuss a little bit, is this really going to solve a lot of our underlying problems in security? Should we really focus all of our attention on it because it's sort of what's going on in the future? So here's a couple of definitions. Statistics is about quantifying numbers. We all have done statistics math, right? You look at averages and the deviations and things like that. Data mining is about explaining patterns. I will show you some visualizations in a second where I have some graphs, and data mining can help you understand what these graphs are about. Machine learning is about predicting with models. What does that mean? Well, a data scientist goes ahead and builds a model based on his understanding of the domain and the data. You build a model. You say, here's what I'm trying to understand. Here's how I model the world. So you have to give the system an understanding of the world. And then the machine goes in and optimizes that and helps you figure out, okay, in this world setup, what are the rules? How do they connect together? How can we make it work? And then artificial intelligence, I'll give you a different definition in a second. It's really something that kind of reasons about stuff, right, or behaves. And I'll show you some examples. So if you look at machine learning and data mining, there's a number of different subcategories, and here's 7 of them. Is it 6? The first one is anomaly detection, where you're trying to find the anomaly in your traffic, in whatever you're looking at, right? Well, when I was at Splunk, this is now a few years ago, I went to my engineers and I said, hey, I want you to help me finding anomalies in this kind of data. And what I had is I basically ran netstat on every machine every hour or every minute, and I looked at how many open ports do I have. And I just wanted to see if the number of open ports is changing, right? So I said, hey, I have this data. Help me understand what's normal in here, or help me understand finding anomalies. And the engineer said, okay, define normal for us. Okay, that's a good question. If a service is restarted, if I configure something differently, I add a new service, these are all normal things, but they will end up changing the number of open ports at the moment in time. So think about whenever you're trying to do anomaly detection, can you actually characterize normal? And if you can't, how can you find anomalies in there? And this is one of the core problems that we're running into with most of these systems out there. Then there's something called association rule learning. There's clustering, where you take a whole bunch of data and you try to find areas that are similar. I'll show you an example in a second. Classification, regression, summarization, the bottom right example there. You have a very complex system that has lots of interactions and you want to simplify it, you want to summarize it, you want to get a higher level view, for example. So these are all topics inside of machine learning. So I'll give you an example here. And in the data mining space, what you see here on the left-hand side is network traffic. And it's an abstract space, so the X and Y coordinate don't really mean much. But you see these clusters very clearly. There's different areas of traffic in here. At least the algorithm thinks so. Now, the first question that you're probably going to come up with is, neat, but what is that pink stuff, right? What is this traffic here? And this is the first problem that you're going to have with data mining, for example. How do you understand what the system came up with? How do you understand why this all clusters together? Is this the web servers and these are my mail servers? Usually it's not how that happens. There's something characteristical in the network traffic that we looked at here that clusters this stuff together. And discovering what it was is actually not that easy. The other thing I did here, I actually ran two algorithms. One of them arranges the dots here. The other one gives the color. So these are just two algorithms, and you see that they actually don't agree with each other very much. You have blue dots, or a blue dot here, whereas the rest is out here, and there's some outliers over here. So you see that sometimes they agree, but sometimes they don't. There seems to be three subgroups in here, whereas this group seems to be closer to this one. So why do they not agree with each other? Why are they not closer to each other? These are all things you have to start understanding. Well, there is areas where machine learning is actually quite useful. But in general, you need a pretty large corpus of data to do machine learning. And one of them is analyzing malware, or you have binaries and you want to understand which ones are malicious and which ones are okay. We have large corpuses of malware out there, right? We have collections where we can really learn what are the features, what are the characteristics of maliciously behaving binaries. So we have a big, big corpus where we can actually learn and start building these models and getting the models better and then classifying malware versus non-malware. So here's a screenshot of a tool called Cynomics that Invincia, which is a company we just bought, has developed, which is very interesting. It actually visualizes your binaries and it lets you investigate how these binaries are similar and classify malware that way. It works pretty well for spam detection. I think if you look at spam, I'm not sure we have really solved it, but if we didn't have spam filters, our inboxes would look very, very different. So I'm pretty happy with the spam filter, except for my email account that I've had for 20 years or something, which is getting flooded with all this spam because I subscribe to everything on the internet apparently. But then let's look at a topic like network traffic analysis. Who has been looking at network traffic like net flows or even firewall log files? A few of you. It's not that easy, right? I've been trying all kinds of things. That's not this slide. You can try to throw all kinds of algorithms at the problem. In the end, what generally happens is that we don't have enough context. What I mean by that, if we look at flows, you have IP A talks to IP B. Well, how do I know if this is normal or not? If you're in a bigger company, you might have no idea what these machines are. And even if you do, you're like, are these two machines supposed to send email to each other? Or is there really a file share that this other machine should access? So the problem doesn't come down to an algorithm that says, oh, here's something funky, but it's coming down to a matter of, well, is it intended to do this? What's the context? What's the machine about? And that's really hard. If you want to find malicious traffic, if you're interested in doing packet analysis and figuring out, well, do we see attacks in here? Well, you need labeled data. You need a data set that actually has a lot of attacks in it so that the system can learn from it. And that has been a very, very hard problem. In 1999, there was a project called Lariat from MIT Lincoln Labs, where they built a test setup to simulate sort of real traffic in a smaller network to then use for anomaly detection algorithms. If you're interested in all of that, there's entire proceedings from conferences, a conference called RAID, Recent Advances in Intrusion Detection, that has been looking at the problem of anomaly detection for network traffic and intrusion detection for many, many, many years. So if you look back in the proceedings, you will find some stuff in there. But they created a pretty good data set that all kinds of researchers started studying their algorithms and measuring their algorithms with. It turned out that there was one feature in the PCAPs, which was the TTL, that gave everything away. So you could look at the TTL and determine whether something was an attack or not. So it is really hard to build these data sets. Even if I came to your company, how do I know that this is clean? And how do I know where the attacks are in there? So it's really hard to build. And how do we build systems without having that data? We can just make assumptions and then go out there and test them. And that's what most security products do. But if you don't have good test environments, how do you know your algorithms really work? So let's address the elephant in the room, artificial intelligence. Well, I spent quite a bit of time in the last couple of weeks reading up on, okay, what's actually happening out there in artificial intelligence? What are people doing? What are different fields doing? What's happening in security? And I think this is very obvious, and maybe Mark take note. Just calling something artificial intelligence doesn't make it artificial intelligence, right? So I was trying to come up with a definition for this. And what I said is, well, a program that doesn't simply classify things like a machine learning algorithm, but it actually comes up with novel knowledge that a security analyst finds insightful. I think that's a pretty decent definition, right? I want to have a system that looks at some data and says, look here, have you noticed this? And you're like, oh, that's interesting. I didn't realize that before. If you apply this definition to systems out there, I don't think you will find much that will actually really match this. If you go into the literature, you will now find that people distinguish three types of artificial intelligence. There is ANI, which is artificial narrow intelligence, which basically means that an algorithm is able to solve one very specific problem. And that's really falling into the machine learning space, right? You build a model, you try to characterize the problem, and then the machine solves it. These are all kinds of things like self-driving cars. It's, I guess, Google Go, right? The computer that played Go. It's Deep Blue, all these kinds of things. Even IBM Watson, I guess, is mostly in this space. It's maybe touching AGI, which is the artificial general intelligence. And this is really what we probably understand is like, oh yeah, this machine is smart. I can reason with this thing, and it comes up with interesting answers for me. And then what's interesting, if you read a little bit about artificial intelligence, you enter the space of the artificial superintelligence. And if you have looked into this space, there's probably a name that you came across, which is Ray Kurzweil, which is a futurist. He works at Google at this point. But he has written a lot about what happens going forward when systems get smarter and smarter, and then he gets into the science fiction world, right? Of, wow, the systems get so smart, they're going to outpace us. What happens then? Here's a graph that I found that tries to explain what's going on. On the left-hand side is sort of our view of intelligence, right? Note how here's an ant, a bird is like twice as intelligent, a chimp is a little more intelligent. And if you look at where we are with AI today, we're close to actually mimic a chimp or a monkey. If you can't read the label here, this little thing says here, oh, adorable, the little funny robot does monkey tricks, right? So we kind of laugh at what's happening right now in artificial intelligence and be like, well, we're not quite there because you still have to traverse all this distance to get to a dumb human, right? And then as like quite a bit more to get to Einstein's level of intelligence. But this is sort of how we think about it. And some people argue that really what is happening is we're over here, where we we have the ant, we passed the bird, and that's actually quite a big jump. And getting to the chimp is also very hard, but it's really not that far away anymore from a human. And people predict that, whoa, this is really going to increase. And if you read up on it, it's quite interesting what they predict is going to happen with systems that are going to be very, very smart and intelligent. But the right-hand side is definitely not where we are with security at all. And here is a couple examples. Machine learning, artificial intelligence, if you just want to be a little sloppy with definitions, lose in a lot of these different cases. I've looked at data, network traffic, all kinds of log files for a long time. And we've tried so many algorithms. We have tried social network analysis. We have looked at all kinds of entropies, and we have used some like self-organizing maps here to try to learn network traffic and find what's normal, what's not normal, classify things. It is really, 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 really hard. Generally, what works is simple. Go back to simple statistics. You can go out there and ask security analytics product companies, what's the algorithm that works best for you? And generally, they will say it's the simple statistical stuff that works, because the complex algorithms, you have all these exceptions, and then you don't understand what they actually learned. So stick with simple. It generally works. So here, for example, what I'm showing you here is a graph of network traffic where different machines are communicating with each other. And the bigger the dots, the more traffic they have transmitted. Now, the question is, in this network, can you find any data leakage? I don't know, right? I mean, you can start running clustering algorithms, and you can start doing all kinds of social network analysis, and you compute the betweenness and the centrality for all of these nodes, and come up with all kinds of algorithms, and do page rank, and I don't know what. And there's entire companies that focus on graph algorithmic analysis of traffic to find anomalies. And generally, it's really just counting how many different machines does this machine generally connect to on how many different ports. You take that over time, and you look a little bit at the seasonalities, and you can come up with some very interesting things that way. The complex stuff generally is not necessary. But what you find here is the same problem that I tried to explain earlier. It's you're lacking context. You don't necessarily know what these IPs are, right? Just because there's a big dot here that one of these IP addresses has talked a lot, I don't necessarily know if that's good or bad. I need to know what that IP is to make a statement about it, right? I did a project for a Fortune 50 company. We took 100 gigabytes of network flows, and we tried to just dig in, hunt, visualize, analyze, run algorithms, and find what's anomalous in here. We found 10% of traffic that came from high port numbers over 10,000 and went to high port numbers over 10,000. Generally, that's not what you would expect, right? You would generally expect traffic to go to low port numbers. If you have a source-destination confusion going on where these things are turned around, you might see the difference, right? Like a low port number going to a high port number. But then you can just sort of accommodate for that and turn it around. But traffic from high ports to high ports is not something you expect generally. And it was over 10% of all of the traffic. It was not like a little bit. Well, okay, there's all the Hadoop stuff that talks on like 50,000. I don't know who told them how to use ports. They're fixing that, by the way. The next versions of Hadoop, they finally go down under 10,000. So they're trying to respect IANA's definitions. There's some Windows stuff, like Exchange will do weird things and negotiate ports. Skype is pretty horrible. If you ever looked at Skype and the network traffic, Jesus, those guys. So it's hard to figure out what's going on without having context. If you don't know what these machines are and what they're supposed to do, you have no way to figure out what's normal. Any machine learning algorithm can try whatever they want if you don't have the right data. What did work in that network is we abstracted things. We said, okay, instead of looking at individual IP addresses, let's look at groups of machines. Let's look at networks and figure out how these networks talk to each other. And suddenly we were able to see some things. We were able to say, this is a secure network, here's the VPN. Anyone coming in on the VPN should never go directly to the secure networks, right? So you can start separating things that way and start finding anomalies that way. But then you find your exceptions. You have one of everything in there. You always had the thing that came from the VPN that went to the secure network with some vulnerability scanner or something, or some network management station that they were testing something, or There's always something happening. So without asset management and actually having a ledger that sort of says what should be going on, again, you have no chance. I'll give you another example of something where simple really works. And this is an example I stole from some friends that work for Etsy. What you have here is the number of fail or password resets over time, right? So I have a website. How many password resets do I see? Password resets could be used for an attack, right? Someone can try out email addresses and try to get an email back and see if a user account exists or something like that. So this is the traffic that you see in the number of password resets over the day. It's very cyclical, right? Now, if I asked you, all right, what are we going to do with this? I want to set up an alert if something anomalous happens here in the volume. Well, we could try to set a threshold here, right? We can say, well, if it goes over whatever this number 0.1 here is, then I want to alert, right? Well, it will alert here, but if you look, because of the seasonality, it's only this little tiny piece here that it actually sort of broke out from. Here, if something anomalous happens at this time, it has to be very anomalous to actually hit my threshold. So I have a pretty bad threshold that way. So what are we going to do? Well, we can use some simple statistics to basically put a curve or fit a curve in here. And there are algorithms that can do that. And then what we do is we measure the distance from the curve and set up an alert on that. So if we do this again, on the left-hand side, I have my curve that I fit. I measure the distance, and in the right-hand graph, I just plot the difference to the actual curve that we learned. So now I can set up a threshold on the right-hand side, and that should actually tell me if something really anomalous happens. You can use this. There's an algorithm called hold winters that you will find in every library out there to just use. You can use this for all kinds of things where you have seasonalities, where you don't want to just have a static threshold, a number of things happening, but how many users are logging into your system, probably very cyclical, right? Maybe even network traffic is quite cyclical. So you don't need very complicated systems to learn something like that, but you can use something like hold winters to do this. And a lot of, actually even security analytics companies are using something like this to kind of learn traffic. Is it foolproof? Absolutely not, right? If the whole volume starts going up and changes this curve, the algorithm will learn that new curve. But if it's just a couple of outliers, it's actually really good at finding that stuff. So in the realm of simple, what I found, and I'm a little biased, is that visualization can really help us looking at data and understanding data. This gentleman here, Edward Tufte, which some of you might know, he's a very famous guy in information visualization. He has written 4 beautiful books on information visualizations. If you ever have a chance to look at his books, they're really beautiful, have history of data visualization. And he said something that really resonated with me. He said, how can we see not to confirm what we already know, but to learn? So how can we look at a visualization of traffic, of security data, to learn something from it? So here's an example of that project I told you about, the Fortune 50 company network traffic. What you see here is port numbers from 0 to 1,000. So this is 1,000 here. So this should all be well-known ports that are being accessed. You see here is a week worth of data. Now, you can look at this and you see all kinds of interesting things, right? There's a lot of traffic here on this port. There's all kinds of horizontal lines where we would expect certain well-known services are being used a lot, right? You have some weird brown lines here, maybe a blue line there, where temporarily in time something else happens across all the ports. Very, 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 very noisy. You can write algorithms to find this stuff. Very easy, right? It's so voluminous. That's not hard. But when we look at this visualization, what you might notice is, what the heck is going on over here? There's, in the first part of the week, none of that shows up. Suddenly towards, I'm not sure if that was a weekend there, suddenly over there, something weird shows up. It's this carpet of traffic there. And writing an algorithm to find something like this is actually not easy at all. Note how it also starts, I don't know, at like 200, right? It doesn't go all the way down. There's something funky going on. In the visualization, You see it right away. There's no question there's something going on here. We need to investigate this. But an algorithm, you wouldn't even notice this in your data if you haven't written the algorithm to find something very specifically like this. So visualization can be very, very helpful for these kinds of examples. Here is, at RSA, I had an opportunity to play with a HoloLens and look at network traffic. So the tool here visualizes a whole bunch of network traffic, and you can interact with it. You see me there trying to click. So like with the finger, you can actually take stuff and click on it, and it was really hard. You can see I'm trying to click on this stuff, and it doesn't react, and then suddenly 10 windows popped up. And the author guaranteed that this was a very quick prototype, and it was kind of fun, but I don't know, like the analytical value, even if the tool, if you had more time to work on something, even if it was better, I'm still questioning the use of 3D and the whole virtual reality to walk around in data. I think it's a great gimmick, but we'll see where this goes. Well, in my last couple of slides here, I want to talk a little bit about, well, I've been bashing security pretty badly right now, so I probably should make some statements on what I see as interesting or what I'm getting excited about going forward. I think some of the areas that I would like to look at a little closer, and I think have some promise, is the first one is we have treated security for a long time as sort of this blanket statement about this IP is bad, if the traffic looks like this, it's bad. So we always said sort of 0 and 1 and convicted the whole world for it. Well, what about looking at sort of environment-specific things, looking at your network and figuring out what's anomalous in your network? How are things set up for you? And that's really what the whole hunting thing, as people call it today, is about, right? You want to have hunters, people that are very experienced, they understand your network, understand what's happening in your network, and then understanding what is anomalous in there. So you need to give them the right tools and start thinking about it that way. And that has a lot to do with real-time threat intelligence sharing. I think the future in threat intelligence sharing is really in real time. It's about companies committing to, when they see something, either automatically or maybe by the push of a button, release that threat intelligence, maybe just to a trusted community, maybe to the whole world. And the companies I talk to that have most success with threat intelligence, for example, in Germany, there's a group of 20 large organizations, including Deutsche Bank, that exchange threat intelligence in this way. They have Soldier Edge set up. They have a trust relationship established between all of them. And they even pay each other for threat intelligence that's released very quickly. They find incredible value in it. They don't look at all these threat intelligence feeds out there that don't really apply to them. Context. I mentioned this a number of times now. I think one of the fundamental problems we have with data analysis is we have not enough context. We don't focus on asset management. If I asked each and every one of you, do you have a handle on the machines that are in your network? All of the machines that are in your network? A couple maybe, but generally this is one of the biggest problems you will find. And this is nothing new. We've known about this for the longest time. We just keep ignoring it. Like, yeah, we'll get to that later, right? So asset management, understanding what these things are. Have you ever seen a tool doing a decent topology map of your network that you actually understand where something is happening and not just like, oh, there's an IP, and maybe mapping it to a switch would be kind of cool. There's some tools that do that. User-based policy, what a great idea, right? It's just kind of obvious. Like, instead of having machine-based policies, what about looking at users and restricting things based on users, right? Firewall rules based on users. What an idea. Adaptive security. Things like, again, not the same like blanket statements for everything, but you see a threat level going up for a machine. My machine gets more suspicious. What about changing or adapting the security posture for this thing? Well, if it does a whole bunch of shady stuff, maybe we want to enforce some more policies. Maybe we want to start doing deep packet inspection on everything the machine does. So that these like dynamic security policy decisions. And then a whole other topic of capturing expert knowledge. I think we're doing a horrible job learning from you guys that really know how stuff works and bringing that back into the systems that we have. If you leave the company today, there's a whole bunch of knowledge that walks out the door. So how can we, I don't want you to write documentation all day, that's stupid. But how can we build systems that while you use them, they'll learn from what you know and absorb that and get better? there's some very interesting stuff to be done there. And forget about 3D visualizations for now and focus on the 2D. We have enough work to do there. So what will change security? A lot of this stuff is already being started and being done right now, but I think continuous authentication. I log in once and then the system is just trusted. Well, why not ask me again to log in or give a second factor authentication when my machine starts to do weird stuff? I'm okay with that if I'm not asked like 10 times a day, maybe once or twice. I'm completely fine with adding my second factor again, right? Dynamic policy decisions, again, I talked about that. Microsegmentation, super interesting, where you basically, there's different approaches, but what you can do is you put something in the network kernel, and every time a network connection is being tried, it calls home to a central controller and asks, hey, this application, this user, can he go to this type of website right now? Control says, yeah, cool, he's in a secure location, he just authenticated with 2 factors, his machine is clean, he can go there. Right? It's a very, very interesting concept. Central controller, all kinds of contexts that you can use there. Real-time threat intel, human-assisted machine learning systems. Don't just focus on making smart algorithms, but how can you build algorithms that humans can interact with? And we, again, that expert knowledge can be factored into these algorithms to help the system. Crowdsourcing, maybe. We've tried in the log management space. At Splunk, we tried Splunkbase. I'm not sure, I think it's still called that, but today it's to host applications on there. The idea of Splunkbase back in the day was we had the interface where you look at log files. You could click on a log file and say, hey, I don't understand this thing. What does it mean? And you would go to this website and explain the type of alert. And then people could go in and say, oh, yeah, I've seen this as well. And by the way, it means this, and you can do that to fix it. It was this whole idea of people contributing to the community. Didn't take off. It's just hard to build a community like that, right? Why do you go in there, spend hours commenting on all these different logs? You just have no incentive to do so. But that's really hard, but I think it's an interesting model. And then there's some ideas of involving the end users. Instead of always escalating stuff to the security analyst, to the SOC, like what is the SOC gonna do if they see someone logging into my server with a weird user account? Like, I don't know, like Chester logs into my server now, and he has never logged in there, and the security team gets a notification like that. What are they going to do? Is this normal or not? They have to call me or have to call Chester to figure out whether it's actually legitimate or not. Well, why can't we send an automatic email to me and to him and say, hey, by the way, there was this login, you guys figure it out. And if I say, Jesus, I never told him to log in here, I'll call him out and be like, hey, what the hell did you do? Then if he says, well, I needed to do this and that, I'm like, all right, cool. But if he says, whoa, 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 it was not me, well, then we can escalate to the SOC, and then they can go and do their work, right? So how can we push these things off to the users for certain problems? Not everything, but this is a big problem, I think, that we're just overloading the SOC with stuff that they should never really have to look at. And then someone please just solve this phishing problem for me. I keep clicking on those things when they have internal tests. So back sort of full circle to the title of the talk, right? We talked a little bit about machine learning and artificial intelligence. I mainly told you that, yeah, what's out there is really not that complicated and not that sophisticated at this point. So how will it help? Well, we need good data, right? Garbage in, garbage out, and we can't, if we don't have it, it's going to be really hard. We're still we have the problem that we need decent data formats. We don't have logging standards. Oh my goodness. CEF, CE from MITRE, the Common Information Model from Splunk. We've tried standardizing these freaking log files so many times, but it's hard, right? Getting everybody on the same page and confirming these log formats. But it's a fundamental thing we have to do in order to do anything on the data analysis side. If we don't know what the data is, we can't write any algorithms. So let's solve some of these problems. Probably someone is going to ask about deep learning, so let's just address it. Well, deep learning is an algorithm out there. It's a machine learning algorithm that has gotten tons of attention. All kinds of fields have been quite, I would say, revolutionized. Image recognition, sound, or voice recognition has made humongous leaps with deep learning. But it's nothing that new, right? We had neural networks a long time ago. They've been around for, I don't know how many, definitely 20 years. But deep learning comes up with some interesting ways of making things work, and they're great for things like malware classification. Again, we have large corpuses of data. Some of the basics of deep learning, and I'm not going to claim that I'm expert in this at all, but one of the things that it really helps you is sort of eliminating the feature engineering step. So for data scientists under you, this is one of the benefits, but applying deep learning to just generic security problems is actually not easy, and in a lot of cases not possible. It will not help you analyzing your network traffic or your flows much better to understand where there's anomalous communications going on. If you're interested in that kind of stuff, sort of data science, I gave a talk a couple of years ago at KDD, the Knowledge Discovery and Data Mining Conference, where I talked about some of the inherent problems that we have in cybersecurity with machine learning, and there's all kinds of things that I'm happy to discuss over beer or coffee or something like that. So where should we use it? It's great for classification problems when we have corpuses of data that we can know what is good and what's bad. We can train these systems. There's a lot of very good work out there. And there's some very interesting stuff that I think is one of the most exciting things for me is there's a couple of startups out there, and actually IBM Watson is trying to do this as well, is automating the level 1 analyst. So basically the people that get all the alerts in, the raw alerts from the systems, and they have to triage and say, oh, this looks kind of interesting. And false positive, false positive. So there's some really, really good work, and a couple of startups I know of people that I really trust and they know what's going on. They're getting really close to automating that kind of stuff. So that's super sexy to me. And look for systems that have humans in the loop. Any system that just says, oh, we have the perfect algorithm to detect this, usually I'll walk out of the room. All right, so a couple more things if you're interested in visualizations. There's this community, secus, go browse around, contribute if you have anything. If you're interested in more on sort of big data, analytics, visualization, I teach a class at Black Hat every year. Encourage you to come join me for that. And then with that, I will open it up to any questions. How do we do this? Do we have people come up here or? No hard questions.
You had an open source visualization tool for your vulnerability management. Do you know what that was called?
NV, no, what is it? I think NV. Nessus visualization or something like that. I can find it. If you don't find it, tweet me or email me, or I'll find it. Other questions? You all want to get to the break. Get some more coffee. All right, I'll be around as well. So if you want to corner me. All right, with that, thanks for being here and thanks for listening.